Welcome to section 2.11 Structures. In this video, I will tell you what is a structure. I will show you how to define a structure and how to declare one. I will show you how to access structure members and how to pass structures as function arguments. I will also very briefly talk about comparing structure elements. So what is a structure? A structure is a collection of variables used to represent complex objects. As an example, you can use a structure to save or to store distance versus time data of a vehicle. You can also use a structure to store a bank's client's information, such as name, address, telephone number. You can also use a structure to represent book information or book details, such as author, title, description, and so on and so forth. To define a structure, we type the keyword struct followed by the structure name. And then we open curly brackets and we declare the member variables of that structure. So a structure representing the speed and time of a vehicle, for example, would be defined as follows. We type the keyword struct followed by the structure name, speed underscore time. Then we open curly brackets and declare the variables representing the structure members. For this structure, we declare two integers, speed and time underscore seconds. This process does not declare a structure, it only defines it. It is as if you are creating your own variable type. You can use the structure to declare a variable that has a type struct speed underscore time. Now that we've defined the structure speed underscore time, we can use it to declare variables of type struct speed underscore time. So if we are trying to plot the speed versus time of a vehicle and we need several points, we can use the structure to declare point 1, point 2, and point 3. Each point would hold the speed of that vehicle at a different time. We declare point 1, 2, and 3 as with any other variable declaration. We declare the type and the name of that variable. Only in this case, the type is struct speed underscore time. So using the examples in the previous two slides, if we wanted to initialize speed, which is a member of the struct speed underscore time, after we declare point 1, we can do it as follows. We type point 1 dot speed equals 0. And we do the same with the other member, which is time underscore seconds. We type point 1 dot time underscore seconds equals 0. And we can do the same thing for point 2 and point 3. Let's do an example now. Please open file example-2-11-1.c in code blocks. In this example, we define a struct distance underscore time, and we define it before main. This way it's global and can be used by all functions. In this example, we only have one function, and that's function main. But in the next example, we will have more than one function. So on line 3 here, we type the keyword struct followed by the structure name, distance underscore time. And then we open curly brackets and we define two variables. Those are the members of this structure. The first one is total underscore distance, this guy here. The second one is time underscore elapsed. So the first one will store the total distance covered by a vehicle, and the second variable will store the time elapsed to cover that distance. Then in main, on line 10, we declare a float variable and we call it average. And then on line 11 to 13, we declare three structures using the structure definition distance underscore time. So we declare speed 1, speed 2, speed 3. We will use these variables to calculate the average speed of the vehicle every 2 seconds. Next, on line 15 to 20, we initialize the struct members. And then on line 22 and line 25 and line 28, we calculate the average speed by dividing the total distance by the time elapsed. And on line 23 and 26 and 29, we use the printf statement to display the time and the average speed at that time. I have intentionally kept the code incomplete, so if you try to compile this code, you will get an error. Stop this video now and try to see if you can figure out what's missing. Okay, if you tried to find the missing code but were unsuccessful, I will give you a hint. Lines 19, 20, and 22 are missing some code. You might want to try again if you are unsuccessful. Okay, if you figured it out, that's great. If not, then on line 19 and 20, I did not specify the members of speed 3. So I have to add the following code. Speed 3 dot time underscore elapsed and speed 3 dot total underscore distance equals 40. And now on line 22, there's something missing as well. If you look at lines 25 and 28, you'll see that I have included the word float between brackets. Here and here. This is called typecasting. The members of the structure we are using are both integers. Total distance and time elapsed. So when you divide total distance by time elapsed, an integer divided by an integer, the result will be an integer as well as far as the compiler is concerned. The problem with that is if you divide 5 by 2, as is the case with speed 1, the result is really 2.5, which is not an integer. So the compiler will ignore the 0.5. It will ignore the fractional part because it thinks that the result has to be an integer. Let's compile and run the code so I can show you what I'm talking about. We come to build. Everything is okay. Let's run the code. Bring this here. And the first message says, at time 2 seconds, average speed was 2 meters per second. This is coming from dividing total distance of speed 1 by time elapsed of speed 1. Total distance of speed 1 is 5 and time elapsed is 2. The result of the division, which is 2.5, gets truncated to 2, and that result is stored in the variable average. Average is a float, and so it will take the 2 and makes it into 2.00. So it looks like a float, but the result coming from the division is incorrect. So what we have to do is we have to typecast or convert the result of the division to a float. So let's add the typecast. And now let's compile and run this code. Let's run the code. And now the message says, at time 2 seconds, average speed was 2.5 meters per second. And the second message says, at time 4 seconds, average speed was 5 meters per second. And at time 6 seconds, average speed was 7.5 meters per second. So we just saw how to declare structure and how to access the structure members. One more thing I would like to mention before we go back to our slides. In the printf statements, the placeholder for a float is %f. You will see that I did %.2f. I added 0.2 between the % sign and f to indicate that I would like an accuracy of 2 decimal figures. Now let's go back to the slides. We can pass a structure to a function just like any other variable, by value or by reference. We talked about this in section 2.10, functions. When we pass a structure to a function, we can access the members of that structure in that function the regular way. We type the structure name, followed by the member access operator and the member's name. That's because we have passed the values of the members to the function that we have called, and those values were stored in a local copy of the structure variable. However, if we pass the structure by reference and try to access the structure members, in this case, the member access operator is different. It is a combination of a dash and a right angle bracket, which looks like an arrow, as shown here. Let's do an example. Please open file example-2-11-2.c in code blocks. Once you open the file, this is the code that you will see. The code is a bit longer, so I will change the view. I'm going to go to View and Perspective. I'm going to change it from Code Blocks Default to Code Blocks Minimal. When I do that, now we're able to see the whole code. Here, we're doing the same thing as we did in the previous example. We declare the structure distance_time. This structure has two members. They're both integers, total_distance and time_elapsed. We will use this structure to calculate the average speed of a vehicle every 2 seconds. But this time, we will use a function to initialize the structure members. We will also use another function to calculate the average speed. This is the first function, which we use to initialize the structure's members. Since we are trying to initialize the members of the structures we declared in main, when we call this function, we need to pass it the structures by reference. That's why this function accepts a pointer to a struct distance_time. This pointer's name is speed. This function also accepts two integers, time and distance. We will pass those two arguments the time and distance values that we intend to initialize the members with. In the function's body, we use the arrow operator here and here to access and initialize the structure's members. And then in the printf statement, we also use the arrow operator to access and fetch the values of the members of those structures. And then in the other function, calc_avg_speed, which we use to calculate the average speed and print that value on the screen, we use the dot operator this time to access those members. That's because when those values were passed onto this function from main, those values were stored in a local copy of the struct distance underscore time. In the function main, we declare the three structures speed 1, speed 2, and speed 3, just as before in the previous example. Init underscore avg underscore speed 3 times to initialize the members of those structures with the appropriate values. After that, we call the other function that calculates the average speed, calc underscore avg underscore speed, to calculate the average speed and print that value on the screen. Now I'm going to go back to the previous view. So I'm going to go to View, Perspective, and I'm going to choose the code blocks default. I will build the code. I have 0 errors, and I will run the code. And as you can see, we have time elapsed 2 seconds, total distance 5 meters, time elapsed 4 seconds, total distance 20 meters, and time elapsed 6 seconds, total distance 45 meters. And they're coming, these messages are coming from this function each time we called it. And then we have the other 3 messages coming from this function, and they are the same messages as the example that we did before. At time 2 seconds, we have an average speed of 2.5, and at time 4 seconds, we have an average speed of 5 meters per second, and at time 6 seconds, we have an average speed of 7.5 meters per second. And so in conclusion, when we pass a structure by value, we use the dot operator to access the structure members. And when we pass the structure by reference, we need to use the arrow operator to access those members. Now let's go back to the slides. In the next section, we will cover conditional statements, where we will compare variables to each other. And so the last thing I would like to mention for this video is that we cannot compare structures to each other. Not directly anyways. We can only compare structure members directly. This is the end of section 2. In the next section, we'll talk about operators and control structures.